and welcome to the video. My name is Jacob. I'm an astrophotographer from California, and today I'm going to be talking about a simple topic that pretty much everyone should know, but for some reason a lot of people can't seem to wrap their heads around the fact that the Earth is not flat and that it's a sphere. Now I'm going to be talking about a couple of reasons why that is, and using my photography to kind of back that up. This is my most recent photo. This is my background on my computer. Anyway, if you want to check out my other photos, you can check me out on Cali_Astro is my Instagram, where I post pretty much all my photos at. Anyway, recently I've been on Instagram a lot, and I noticed a lot of the friends of mine, their photos and just other things related to astrophotography have been recommended to the flat earthers of Instagram. And I just can't help myself. I always look in the comments just to see what kind of dumb stuff they're saying, and it's always like the same kind of thing, like, oh, the Earth doesn't rotate like that, stuff like that. And I'm just gonna talk a little bit about why Earth isn't flat. I'm not gonna talk about really anything too crazy, because most of them can't wrap their heads around the fact that it's not flat. So I have this super insane simulation software that I developed, and yeah, it's insane. So let's say you take a pole, any pole, and you take a sphere, some ball, you stick the ball through the pole. Okay, so now the ball is stable. The ball, if you move it, it will only rotate like one way, and that's kind of what I have here. So here's your ball, and that's the pole. Now the Earth rotates like that. If you spin it, if you take a ball and you spin it, that's how the Earth rotates. Now the Earth is on a slight tilt. It's a slightly tilted axis. Anyway, forget about that. Even if the axis isn't tilted at all, let's say it's not tilted and it's rotating, you'll notice that on the top parts, it doesn't really move. It kind of spins, but it kind of stays in the same spot. So if you were standing right here, the stuff over here would look the same. But if you're standing, let's say, like right there, right here, all this stuff would be moving. It'd be changing. You'd be seeing stuff over here sometimes and stuff over here sometimes. And that is the same exact thing in space. Or not in space, on Earth, because we are rotating. So there's a thing called Polaris. It's a star in the north. It is a star that we use to do a thing called polar aligning, where we line up our mounds that track the sky with Polaris, because it's very close to true north. It's not quite true north, but it's very close. It's a bright star. And here's a photo I took of it about a year ago, and it is actually a triple star system. There's one right there, and I don't know the other stars there. Anyway, it's a pretty bright star. It's a pretty big star. Kind of hard to miss it. The North Star, aka Polaris. And in the night sky, if you notice, things like every other star will move considerably throughout the sky, while Polaris kind of stays right where it's at. And that is because we are spinning. And Polaris, since it's north, you don't really see it. Like, this is, oh, we're moving. And Polaris is just kind of sitting there, not really doing too much. It might be a little bit off true north, which so it moves slightly, but it doesn't really move quite like everything else. Now, another thing I want to talk about is it's the same thing in the south. Now, the south doesn't have like a star per se that shows like true south is quite like north. Like, we're pretty lucky to have a star as bright as Polaris, pretty close to true north. And I wanted to explain another thing, why we're not on a flat planet. And that's because we see two different skies in the north hemisphere and the southern hemisphere. Now, I drew the Earth right here. I'm in America, so I'll put me, and I kind of tried drawing America. And this is Earth. This is where you are right now. Earth. I think. Hope I didn't spell anything wrong. And this is south, and that's north. And I put a little arrow to it, so you guys know this is north and this is south. You got like Antarctica and South America, all those places. Anyway, in on the equator, this is right here, it splits north and south, and depending on how high in degrees you are from the equator will depend on what sky you see. So me being about right here in California, and towards the middle of the California's towards the middle of the country, I'm gonna see the stuff in the north, all this stuff. Now I can see a little bit of stuff in the south, very little bit of stuff. It pops its head up for a little bit, but for the most part, I'm seeing everything in the north. All these cool stars in the north. That's all I see. But in the south, let's say you're in, I don't know, Brazil or something like that, or maybe even more south, like you're in freaking the South Pole. You're gonna be seeing everything in the south, and it is completely different skies for the most part. They're completely different for the most part. You have completely different everything that you won't be able to see in the north that you will in the south, and vice versa. And yeah, if we're on a flat planet, let's draw it over here, it's a flat planet, wouldn't we see the same stuff everywhere? Like, why do we see a different, sky over here than over here, and vice versa? It just doesn't make sense. It's because we're on a sphere, a rock in space, that's spinning, and not a flat plane. That's all I have to say. Hope you liked my super sophisticated recreation software. Sorry if I sound kind of weird, I'm a little sick right now. But yeah, hope you enjoyed. Bye bye.